Some of you still for star and I ready. I don't have to tell you who you are. By now you should know who you are. Multitask the best you can. Add me in 3. Today Thursday 7/25. February 25th. 7 SBC. I can find experimental probability and make predictions using proportions with 60% accuracy. Yesterday we began looking at probability. Somebody said me something we learned yesterday about probability. What did we do yesterday?
We were talking about origin and probability.
All right, so we say the probability is certain if it's close to what? 1. Good. What else did we know?
Impossible is 0.
Impossible is 0. Anything else? Less than a half, and then we had 1 greater than a half. Likely is not, and then at a half. Equally likely. I got it. Y'all said a few words back, but that's good enough for me. It works good. So today we're going to keep working with probability. How do we set up that probability and figure out if they between 0, 1/2, or 1? We didn't do a number line quite exactly. Somebody said something. Made a fraction. After we made that fraction, we did what? Good job. So we're going to be doing the same thing today. Remember that you are a champion, as I told us yesterday, regardless of how often you hear good affirmation. You are a champion. I do believe in you. I got confidence in you. We're going to get through this. We got about 3 more days of instruction. I'm teaching you today. I'm teaching you Monday. I'm teaching you Tuesday. Then we're moving into review for 9-week tests and hopefully to get some of us caught up with missing work. All right. A little more vocabulary. Piggyback from yesterday. Probability is the likelihood of an event happening. Outcome is one of the possible results of the experiment. If I have a coin, what's my outcome? Or good job. And then if I do an experiment, that's a procedure that infinitely repeated. So if I was to take that coin and flip it 25 to 30 times, I now have an experiment. We can use a notation P of an outcome to represent the probability of getting the outcome. So sometimes when they want you to find the probability, they will put a P, a big P, in what they want you to find the probability of in parentheses. So if I see P of star, that means to find the probability of how many times I pulled the star. Experimental probability is what we're mainly looking at today, and that's the probability of an outcome from the experiment. So they're going to give us the data that they did in the experiment, and we're going to use that data to figure out the probability. It works similar as yesterday. We're going to be writing a fraction. Of course, the numerator is the number of times that event occurs, and the denominator is the number of trials. I also like to think of that denominator as the total. To take us back to 4th grade, that denominator is always that total. I also told us a few words to pay attention to, or, and. If they say find the probability of a star or a diamond, that means I need to add those values together. I want both. If they tell me to find the probability of a star and a diamond, and would tell me to multiply. So just a few key words to pay attention to. Any questions about vocabulary? All right. You can go ahead and find your practice. It is in the new usual place in Schoology. For those of us who still may not know how to access it, we are February 25th, so it'll be in the folder of February 22nd. And of course, today is Thursday, so it is your Thursday's practice down at the bottom. We there? Internet slow? How we looking? Internet slow? You said there? Okay. Those of you at home, I hope you there as well. If not, just take some time to get there. As I said before, if you need to write on a piece of paper and transfer it over, however you see fit. I don't look at answers, so that means whatever I write, you pretty much need to be writing or typing in your box. All right, question number 1. It says a spinner is divided into 5 equal sized sections, lettered A to E. Kyle spins the pointer on the spinner 25 times. He records his results in the frequency table at the right. How many times did he spin it? So that means 25 would be my what? Good job. That's my denominator. So now A told us, based on these results, what's the probability of the pointer landing on D? How many times did it land on D? And Tamir, you said that denominator is what? Good job. 4 out of 25. Kaden, you told us earlier after we write the fraction, we do what? Go ahead and divide it. Not 25 by 4, 4 by 25. All right, 0.16. Good. All right, and then we got B. It asks what's the probability of the pointer landing on a vowel. Three for E. Any other vowel? 3 plus 6. And what's that denominator? Good job. Kaden? Good job. Any questions about finding the probability from an experiment? They're going to give us the data, and we use that data to get the probability. Anybody still getting anything? You said hold up? Okay. Oh, I'm all right. Yes, ma'am. So, from the last mention that they talked about it, they mentioned that they would do transportation. But what I can do, I can check and see if he's on that list for transportation. And if not, you may just have to bring him. Okay. Well, I'm going to, as soon as I get out of class, I'm gonna refer that message to administration to make sure he's put on that list. And the only thing about that, if they don't show up in the morning due to the bus drivers getting the list at the last minute, you may have to bring them in the morning, but he can ride it. We usually get started about 8. Yes, ma'am. Either one, and we'll make sure he get what he needs to get. Yes, ma'am. All right, somebody go ahead and read it to us.
Students and plan to bind the results of their experience rolling a number cube. The results are shown in the table at the right.
I'll read. You heard me, kid?
How many times each one?
What'd you say, Elijah? I think that was you.
I said I'll read.
All right, they just read it. They didn't hear you, but that's fine. All right, so students in Luke's class, he did this, and then they say we need to do it 1,000 times. Before we look at 1,000 times, somebody go ahead and get us that overall total.
What number rolled?
How many times he rolled all of those numbers? Get the total. All right, here, 121. Somebody read it back. 171. 171. 200.
I got 200. Oh, I forgot to add the 35. Yeah, 200.
All right, so 200. They want us to look at each of these numbers and see now what will be the trial at 1,000. So that means we're going to take 1. And right now we got 32 out of 200, correct?
Yeah.
That new denominator is going to be 1,000 because they now want us to compare it to 1,000 times. Somebody divide out 1,000 by 200. All right, 5. All right, multiply 5 by 32. 160. So that means in 1,000 trials, we will get 160 times. Do we know the value of any other one? Just based on finding 1. Good job. So I would say 4 is also 160 times. And it could be on the same line with 1 showing us why they're the same. Blue and white. Always get it when you come to school. All right, y'all with us?
Yeah.
You lost?
Yes, sir.
You said you lost? Oh, okay. All right, y'all with us?
Yes, ma'am.
All right, let's look at 2. 2 told us we got how many right now? All right, 33 out of 200. They said we doing it how many times? 1,000. We already know that was 5, so multiply 33 by 5. I would say 2 would be 165 times. You know me and wondering about your answer. You should know I don't look at an answer. So that means you need your fraction, you need your fraction equivalents. All right, looking at 3. All right, somebody said 34, and we already know that's out of 200. We already know we're trying to get to 1,000. So we already know we multiplying by 5. All right, so that also means we know which other one. We got 1, 2, 3, 4. We got 5. Now looking at 6. 35 out of 200. We're trying to get to 1,000. We already know multiply by 5. Here 175. still typing?
No, ma'am. Yes, ma'am.
All right, let me know when you finish, okay?
Yes, ma'am. Okay.
All right, anybody else? All right, looking at the next one, a bag contains blue, red, and green marbles. Paula draws a marble from the bag, records its color, and puts the marble back into the bag. Then she repeats this process. The table shows the results of her experiment. It says, based on the results, which is the best prediction of how many times Paula will draw a blue or red marble in 5,000 tries? I see blue or red. What do we say or mean? Good job, Andy. So how many total blue and red do we have? Out of how many total?
60. I mean 50.
Total. That means all. If that's 44, we add 6. So 44 out of 50. Now they told us we doing how many trials? 5,000 is our new denominator. So somebody tell us 50 times what is 5,000?
100.
All right. So now multiply the top by 100. Good job. Multiple choice ones are the easiest one, so you ain't got to type down with it. Any questions about how that's C? Okay. All right, somebody read number 4 to us.
The numbers of people in one selection of the school for each of 18 female students, 16 male students, and 6 people. There are 720 people in the auditorium. Consider the possibility of selecting one at random for the auditorium.
All right. So they told us how many is in this section that he has. 18 females, 16 males, 6 teachers. How many total people is in this section? 40. And then overall, how many total people in the auditorium? 720. All right, so it's a choose all question, so that means we need to try them all out just to see. So the first one said of selecting a teacher. So right now we know we got 6 out of 40. And then if we get that equivalent with 720, so now divide that out. 8. 6 times what? 18. And 50% of 108 over 720. Shift 2 times, 15%. Is that what they told us?
No.
All right, so let's try the next one. They said selecting a student is 85%. How many students we have right now? 34 out of 40. We got 720 total. She told us that'll be multiplying by 18. So go ahead and multiply by 18. $612.
Yes, ma'am.
All right, now divide that out so we can get the percentage. All right, shift 2 times. Good job. All right, C said of selecting a male. How many male students we have?
16.
All right, 16 out of 40. We already know we're going to multiply it by 18. 288, divide that out. Here 2 times, 40%. That ain't what they told us. Let's try the last one. How many females?
18.
All right, so then 18 out of 40. Denominator 720. Go ahead and multiply it by 18. All right, divide it out. Here 2 times, 45%. So we should have B as well as D. Any questions about it? No, you can't talk. Yeah. Come here. Come here. I want to make sure before I eat it. All right, somebody read to us about Jackie.
Jackie used an app to simulate corn with 400 tires on the head, 222 tires. Based on their results, Jackie predicted the effective number of tires of corn will remain on head is 10,000 pounds to 5,000 pounds. Do you think Jackie expected results are correct as far as your reason?
All right, let's see about what Jackie said. She flipped this coin 400 times. She landed on heads 222 times. So she said in 10,000 trials, we should have about 5,000. Do y'all agree with Jackie?
You gotta see first.
Gotta see first. Let's see it. We got 222 out of 400. Now they told us we're doing 10,000 trials. Somebody divide 10,000 by 400. 25?
45 times 45.
All right, multiply that by 222. Y'all mumbling after you say 5,000.
550.
Did she predict correctly? No. What you know about 400 and 222?
400 and 822, they're equal, even.
Outside of being even, what is all right, what if I take 222, what can I round it to? 200 is what to 400? What's half of 10,000?
5,000.
So can I now say that she's correct? Yes, she estimated it. So we can say, yes, Jackie is correct. Because 222 is about half of 400. And 5,000 is half of 10,000. She estimated. computer still clicking. You got it? Alright. I think you got about 13 questions. As always, we're gonna try to get through as much as we can, so we can submit and at least get 1 grade for math. All right, somebody read to us.
Collection manager records the number of orders for each appointment available. The results are shown in the table. Determine whether each of the following predictions can be made. Results. True or false for the prediction.
All right, now this one, some of y'all will go through and give me true, false, true, false, true, false, and then you wonder why I say you only receive half credit. So I mean, whatever we say true or false, you need your fraction to prove why you're saying true or false. All right, so the first one they asked us about water. What's our total overall, first of all?
105.
Clearly not. I hear 500.
I got 500.
All right, the first thing they asked us about is water. How many times did we get water?
160.
All right, so we know that's 160 out of 500. And then they said about 15 of the next 50. So that means 50 is my new denominator. 500 divided by 50 is what? 10. Divide 160 by 10. Is that what they told us?
Yes.
10, if it's all 2. They told us 16, we got 16. All right, B said we're now looking at lemonade. How much did we already have for lemonade? All right, 145 out of 500. How many are we looking at now? 100. Y'all said that one true?
No, ma'am. Wait.
Yes, it is true.
Yes, ma'am.
All right, so you divide that by 5 and you got 15.
Oh, I come out 8.
So I will have false, and then I will have my 2 fractions. 145 over 500 is equal to 29 over 1. All right, next we're looking at T. How much do we have for T? 90. 90 out of 500. How much are we looking at now? Good job, 150. Somebody divide 500 by 150. All right, she said 3.33 repeated. So divide 90 by 3.33 repeated. Is that what they told us? All right, now they said for orange juice. How much we got for orange juice? Out of 500. What's our new denominator? Good job. Somebody divide 500 by 200. All right. Divide 105 by 2.5. Are you 42? Is that what they told us? All right. Now they said water or tea. How much do we have for both? Water and tea. Check again. 6 plus 9. All right. What's our new denominator? All right. We already know that's 5. Divide 250 by 5. Is that what they told us? Nope. All right, let's try the last one. Lemonade and orange juice. How much? Alright, I got it 2 times. What's our new denominator? Alright, we did that one earlier and said that was what, 2.5? So divide 250 by 2.5.
100.
You know what I said in the beginning, most of it hands off on his part, so we don't want to be too far. Put your work to show me you at least know something. Even if I copy this straight from the board, guess what? I'm gonna type it in as if I did it myself. Wait,
Can I just use the work that I do?
What's that number right there?
this slash, you see the slash?
Is that 2.5 or what?
Yeah, 2.5. Fraction. You fine. Just let me know y'all finish. And yes, so I hear.
Because it had day and night like us, and most of it well, some of the time the full moon isn't showing. But when it's full moon, it's the sun is shining directly at it.
Yes, ma'am.
You already know when you got.
You sure? You sure?
Yes, ma'am.
All right, somebody read number 7 to us.
A star is divided into 5 sections led by A, B, C, D, and E. Benefits of 50 times on recorded results in the table.
All right, so now the first thing they asked us about when they came and said 1,000 times. So let's go ahead and get our total in that table. All right, I hear 52 times. All right, now the first thing they asked us about was landing on B. How many times did we land on B?
14.
All right, so that'll be 14 out of 50, and they told us our new denominator is what?
1,000.
50 times what is 1,000? Wait a minute now. I heard 10, I heard 20, both real quick. All right, so 14 times 20. It went out.
280.
All right, so that means we will land on B 280 times. And of course, you'll have your fraction with it. Show the equivalence. Landing on a vowel. I hear 8. A and E, okay, so that's how many total. So we got 16 out of 50. We already know that the denominator is 1,000. Somebody said we'll multiply by 20. I hear 320. 320 times. Any questions about what we doing? By now we done kind of caught on to how it's working. So if you still tapping, you good?
Yes, ma'am.
Alright, the spinner got the sun, moon, and star section. Can be recorded her results on the spins. Based on the results, predict how many times the pointer will land on the moon in 500 spins. Alright, let's first figure out how many total spins are over here. Here's 60. 60. Alright, moon had 18 out of that 60. Now what's our denominator? Alright, divide it out. 36. 60 times 36 is 500.
Oh, I hear 18 on that.
No,
We got 10 more. Alright, so then multiply 18 by 8.33.
160.
160.
what are you doing?
I got one. Alright, so somebody check. I got two different answers.
Oh, I divide.
I got 149.94.
1.9.94, that may be what she had.
Yeah, I divide.
So 1.9.94, we can say that's about 150 spins. Good job. All right, 9 reads. The owner of the deli recorded the number of customers who ordered each of the 4 sandwiches. If the deli has 50 customers, the first hour is open. Predict how many customers will order total. Go ahead and get our total in that table. All right, I hear 500. All right, turkey, we had 180, so we know that's 180 out of 500. What if they tell us our new denominator is? 50. Good job. 500 divided by 50 is what? Divide 180 by 10. So then we have 18 turkey sandwiches. Any question about what's going on? Got a cow. Who else is that? My kids got. Williams, I mean. All right, we got about 4 more. Let's see if we can get through. Make this a bit small. All right, Ryan got a bag of marbles. He selects a marble without looking. He puts it back. They say he did this 25 times. He did green 10 times, and then he selects blue the other number of times. Based on these results, what's the prediction that he will get a blue marble 100 tries? So we know he did it 25 times. He had green 10 times, and blue was remaining. So how many times did he hit blue? Good job. All right, now they told us 100 tries. 25 times, what is 100? And then 15 times 4. Good job. Correct answer would have been D. So that's the first thing I would say. The correct answer is D. Most of us will tell what the person did wrong, but we don't give the correct answer. All right, so then they said he chose B. How do you think he ended up with B? Don't tell me what he probably did. Tell us what he did. Green had 10 out of 25. Great job, Al. So then I would say Ryan is incorrect because he found the probability of the green marbles instead of the blue marbles. So he probably should have reread the question. All right? All right. In the cafeteria, there are 7 teachers, 48 girls, and 45 boys. What is the probability that a person chosen at random from the cafeteria is a boy? How many boys we got? How many total people in that cafeteria? All right, simplify 45 out of 100. Think about something they have in common. 5, all right. 45 divided by 5, and then 100 divided by 5. I can go with 20, check the top. Any questions about those two? Y'all still getting anything? Now, know you got it tonight. Is it 1 or 2? We're gonna try to squeeze it in. We got about 4, 5. We're gonna try to squeeze it. Yeah, 14 and 1 for your work. So it should, yeah, we got 2 more, 12 and 13. You got it tonight? All right, I'm gonna try to put it on the same page. It just may be a little small. I'm sorry. And I'm still not fitting it. Don't worry about it. We're gonna do it one at a time. All right, students in math class were divided into 3 groups. Each group was given a paper bag filled with an unknown number of marbles of unknown colors. Each bag or marble was drawn at random and then put back. Each group repeated this procedure until they recorded 50 draws on the bag. The data is shown in below. A says in bag B, it appears to be equally likely to draw a white marble as it is a yellow marble. What did we say equally likely meant yesterday? Good job. Okay. So let's look at white and let's look at yellow. Go to bag B. And we already know each bag got 50. Let's say white would be equally likely to draw than as it is a yellow. Is there an equal chance of being white and equal chance of being yellow? Yes, so they got the same number. So I would say same amount. All right. The next one says the probability of drawing a yellow marble from bag C is approximately 7%. All right. Bag C, yellow, 7. 7 out of 50, gonna give me 7%. 0.14. So I would say false. It would have been 14%. C says the probability of drawing a purple marble from A after 200 draws is likely 0. A purple marble from A after 200 draws would likely be 0. All right, find bag A and find purple. How many we got? 0. So if I do that 200 times, it'll still most likely be what? Yes, that is true. If I don't have none now, if I keep doing it according to this experiment, I still won't have it. D said if the marbles from bag C were drawn 10,000 times, about 600 red marbles will be drawn. Well, let's see, they said red. So that would have been 3 out of 50. And then they told us we trying it 10,000 times. Somebody tell us 10,000 divided by 50. 0.5? You divided wrong. So then 200 times 3 will give us 600. True or false? Good job. All right, and then E said each bag definitely contains an equal number of marbles. Equal number of marbles. Would you say red is equal in each bag?
Oh, no.
So yeah, that's false. That's what they meant. Each bag gonna have the same amount of each color. Any questions about it? I'm gonna try to make it through this last one. Y'all still getting it?
Yeah.
All right.
Tomorrow.
So we did C. Oh, for C, say it was already 0. D, we did it over here. 3 over 50 equals 600 over 1,000. I mean, 10,000.
E is false because they don't have the same amount of marbles in each bag.
Yes. We got it. Yeah.
I got it.
You got it, Mikey? You sure? You sure? All right, last but not least, students spin a spinner 500 times until the table shows the results. Based on the results, predict the number of times the spinner would land on blue in 100 spins. First, get our overall total. All right, they asked us about blue. Blue, we had 150 out of that 500. Now they said our denominator is what? Good job. We know that to be 5. Divide 150 by 5. All right, so then I would say blue 30 times, and there's your fraction equivalent. That's good, but I mean, everybody should once again be ready to hit what? Yes. Everybody should be ready to hit some.
Your junk probably sound like your junk sound. Yeah, your junk definitely sound like Kennedy don't be all in the mic. Your junk be so annoying.
That's 10. 10 here. All right, y'all got it?
Yes, ma'am.
Got it, my kid? All right. All right, those of you at home, just like I just told them, we finished all of today's practice, so you should be ready to hit submit. I hope you have a good rest of your, what's today? Third. See you later.